Good morning, grade 10s. I hope you had a good weekend and I hope that you're all keeping safe and healthy. Today we are going to be carrying on with Euclidean Geometry, and you will see that today's video will cover your work for today and for tomorrow, and the exercise that you're going to be doing will be split up between today and tomorrow. We are going to be focusing today on other quadrilaterals. Before we do that, I'm going to do a short recap and we're going to look at some of the properties quickly. So in today's work, they are going to be telling you that you have got a quadrilateral, and they're going to ask you to prove that the quadrilateral is a rectangle or a rhombus or a square or a trapezium or a kite. So in order to do this, it's two steps that you need to follow. The first is that you need to first prove that your quadrilateral is a parallelogram, and you can do that using one of the 5 ways that we learned about last week. And then the second part is you then need to prove one of the properties of that specific quadrilateral. And we're going to look at those properties in a few seconds. To recap quickly, just remember that there are 5 ways to prove that a quadrilateral is a parallelogram. You have to be able to prove one of these 5. So they are: opposite sides are equal, opposite sides are parallel, opposite angles are equal to each other, diagonals bisect each other, and one pair of opposite sides are equal and parallel. You should know those 5 ways off by heart by now. The first quadrilateral that we're going to look at is a rectangle, and you will see the properties of a rectangle are listed there. You can see the opposite sides are equal and parallel. You can see that the diagonals are equal and they bisect each other. You can see that D1 is equal to B2. So basically what you're looking for there is alternate angles. So you can see your alternate angles are equal. So D1 is equal to B2, D2 is equal to B1, A1 is equal to to C2, and A2 is equal to C1. So your alternate angles are equal. And then what you should also see is that your opposite angles are equal. So angle A is equal to C, B is equal to D, and the 4 corner angles are equal to 90 degrees. Now, if they ask you to prove that a quadrilateral is a rectangle, you would need to prove, first of all, that it is a parallelogram using one of the 5 methods we learned last week. And the second part is you would have to prove that at least one of the corner angles are equal to 90, or that the diagonals of the quadrilateral are equal in length and bisect each other. So if you can prove it is a parallelogram and prove one of those 2 additional reasons, then you can say your quadrilateral is a rectangle. The second quadrilateral that we're going to look at is a rhombus. So you will see the properties of a rhombus are listed there. You can see the opposite sides are equal and parallel. You can see that the diagonals bisect each other. You can see that the diagonals bisect the corner angles. You can see that the opposite angles are equal to each other. And you should see that the diagonals intersect at 90 degrees. Now, if they give you a quadrilateral and they ask you to prove that it is a rhombus, you would need to firstly prove that it is a parallelogram using one of those 5 methods. And additionally, you would then need to prove that one pair of adjacent sides are equal, or you would need to prove that the diagonals bisect at 90 degrees at right angles. So you would prove it's a parallelogram, and then you would see which you could prove either the adjacent sides are equal or the diagonals bisect at 90 degrees. Once you have proven that, you can then prove that it is a rhombus. Thirdly, we are looking at a square, and you can see there your properties of your square is that all 4 sides are equal. Your opposite sides are parallel to each other. You can see that your diagonals are equal and bisect each other. You can see that your diagonals bisect the corner angles. You can see that the corner angles are equal to 90 degrees. You can see that the diagonals intersect at 90 degrees. So those are all of your properties of a square. Now, if they give you a quadrilateral and they ask you to prove it is a square, firstly, you need to prove it is a parallelogram using one of those 5 methods. Once you have done that, then you can prove one of the following 3. either that the quadrilateral is a rectangle with a pair of adjacent equal sides, or that the quadrilateral is a rhombus with a corner angle which is 90 degrees, or that the quadrilateral is a rhombus where the diagonals are equal. So you would prove it is a parallelogram, and then you would choose one of those three reasons. Once you have done that, you can then say that your quadrilateral is a square. Now, when it comes to a trapezium and a kite, it works slightly different. You do not need to prove that it is a parallelogram. All you are going to do is you're going to look at the properties of your trapezium, and you are then going to prove one of them. So if you look at the trapezium that we have got there, the only property we know about a trapezium is that it has one pair of opposite sides which are parallel. So in order to prove that a quadrilateral is a trapezium, you would need to prove that it has one pair of opposite sides which are parallel. So you're not proving anything about a parallelogram. You're going straight from a quadrilateral to a trapezium, and you would just prove that there is one pair of opposite sides which are parallel to each other. And the same goes for a kite. You're not proving that it is a parallelogram. You're going straight from a quadrilateral to a kite. So if you look at the properties of your kite, you can see that your adjacent sides are equal in length. So the top two are equal in length and the bottom two are equal in length. You can see that the opposite angles are equal in equal in size, excuse me. You can also see that the diagonals intersect at 90 degrees. Okay, so if you want to prove that a quadrilateral is a kite, you would need to prove that the pairs of adjacent sides are equal in length, and that will prove that it is a kite. So like I said earlier, there's no need to prove one of the 5 ways of proving a parallelogram. You would go straight from a quadrilateral to a kite. You will see that today we're going to focus mainly on a square, a rhombus, and a rectangle. Alright, grade 10. So the first example I'm going to do with you is in your textbook, page 197, and I'm doing question 3. So if you have a look here, they've told you that ABCD is a square. They've told you that angle AEB, so this angle here, is 55 degrees. So I'm going to fill that in, 55 degrees. And then they've asked you to calculate angle F1, which is that one. So the first thing we're going to do is we're going to work specifically in this triangle here. So I'm going to write there in triangle AEF. The first thing that we can see, angle E1 is equal to 55 degrees, and that was given. Okay, the second thing that we should know, because this is a square, they tell us it's a square, we should know that our diagonals bisect the corner angles. Now these corner angles of a square are 90 degrees. So if my diagonal bisects 90 degrees, it means that A1 and A2 are both equal to 45 degrees. And that's going to be my second point. I'm going to say that angle A1 is equal to 45 degrees. My reason would be the diagonals of a square bisect the interior angles. Okay, so now that you would have only been able to know if you knew your properties of a square. If you didn't know the properties of a square, you would have missed that. Okay, and now you can see in this triangle we have got E1 is 55, we've got A1 is 45, and from there we know the interior angles of a triangle are equal to 180 degrees, so F1 is easy for us to work out. So we can then say therefore F1 is equal to 180 minus 55 minus 45. So we get F1 is equal to 80 degrees. My reason, interior angles of a triangle are equal to 180. Okay, so just to recap, they told us that E1 is 55. We worked out A1 is 45, and we did that because the diagonals of a square bisect the interior angles. So those are equal to 45 degrees each. Once we knew that was 55, that was 45, we could then say the interior angles of a triangle are equal to 180, so we could subtract those two from 180 to get the size of F1. Okay, next I'm doing question 4 in your textbook, page 197, and this will be for Tuesday the 12th homework. So the first thing is that they tell you that PQRS is a rhombus, so that should already make you know, or make you think that the opposite sides are equal and parallel, and we'll get into the other properties now. They then tell you that PQ, so this length here, is 26 centimeters. I'm going to fill that in. They tell you that QS, so this diagonal there, is 48 centimeters, and they're asking us to calculate the length of PR, so this PR, this diagonal here. So the first thing that you should be able to identify is I'm going to work in one triangle, and you should see that this diagonal QS is 48. Now you should know the properties of a rhombus is that your diagonals bisect each other, which means that QT is equal to QS, and they should both be equal to 24 centimeters. So we'll get to that in a minute. The first thing we're going to do is I'm going to say in this triangle, because that's what I'm working with, in triangle PQT, the first thing is that PQ is equal to 26 centimeters, and that was given. Straightforward. So we're obviously looking at the length of these three sides here. So the next thing, in this length QS, they tell us is 48, we know that the diagonals bisect. So QT is equal to TS, and they should both be equal to 24 centimeters because our diagonals bisect. The reason would be the diagonals of a rhombus bisect each other. Okay, so I'm going to fill in there that this is 24 centimeters. And now we want to work out the length. If you look at this triangle, if we can work out the length of this side there, then we will know what the length of this side is because the diagonals bisect each other, which means we will know the full length here. So I'm focusing on this triangle there. Now what you should know is that in a rhombus, your diagonals bisect at 90 degrees. So that is a 90-degree triangle, and that should already ring a bell for you. You should realize that in a 90-degree triangle, when you're trying to work out the length of an unknown side, you're going to use the theorem of Pythagoras. So what I'm going to do is I'm going to say PQ squared. You can see that PQ is your hypotenuse. It's opposite your 90 degree. So PQ squared is equal to QT squared plus PT squared. Your reason would be Pythagoras. I'm then just going to substitute in my values. So PQ is 26 squared is equal to QT is 24 squared plus PT squared. I'm now going to try and get PT on its own. So I'm going to minus this. So I'm going to get 26 squared minus 24 squared is equal to PT squared. When I calculate that, I get 26 squared minus 24 squared is 100 is equal to PT squared. But we want PT, we don't want PT squared. So I'm now going to square root both sides, and you can see that PT is equal to 10 centimeters. Okay, so that means if this side here is equal to 10 centimeters, it means that this is also equal to 10 centimeters. So you could say then that that PT is equal to TR, which is equal to 10 centimeters. The reason there would be the diagonals of a rhombus bisect each other. And from there, the question asks us to calculate PR, so you can see that PT plus TR is equal to PR is equal to 10 plus 10, which is 20 centimeters. Okay, so just to recap what we did there, the first thing is we just filled in that QP is equal to 26. We then saw that QS is 48, so QT and DS are equal to each other because the diagonals of a rhombus bisect each other, so therefore QT is equal to 24. We also saw that this is a right-angled triangle, so to work out the side of the unknown we would use Pythagoras, and we would then say 26 squared minus 24 squared gives us PT squared. We worked out that PT is 10, PT is equal to TR because the diagonals bisect each other, which means that they are both equal to 10 centimeters, so therefore PR is equal to 20. Okay, grade 10, so that brings us to our homework for today. You are going to do exercise 5 in your Mind Action Series textbook, page 197, and for today you are going to do question 1, 2, and 3, but you would have seen that I've already done question 3 with you as an example, so please do rewrite that one in your book, and then you are going to do question 1 and 2 on your own, and we will put up the memo for that tomorrow, and then tomorrow you will do the rest of the exercise, which I will indicate in a minute. Okay, grade 10s, and then the last thing for today is your homework for Tuesday the 12th of May will be to carry on with that activity. So Mind Action Series, page 197, exercise 5. You're going to do question 4, 5, and 6, but you would notice that I've already done question 4 with you in the example, so if you could please just rewrite that in your book, and then you're going to do question 5 and 6 on your own, and we will mark it tomorrow. Alright, grade 10s, I hope this video has helped you. Please, if you are stuck with the activities, ask your teachers. They are more than happy to help. And I hope you guys enjoy the rest of your day. Cheers, bye-bye.